Hey everyone, Ronak this side. I hope you all are doing well. So let's get into the problem of the day. So the problem we got here called the jump game 4. So basically the problem we saw the previous day and yesterday is it's similar to that kind of like we have given an array considering. Let's consider this array. So at previous class you saw that if you are given an array like 1 to 3, at 3 you can jump 3 step back or 3 step front. At 2 you can jump 2 step right or 2 step left. At 1 you can jump 1 step left or 1 step right. Okay. So the difference here is here you can jump I plus 1 or I minus 1, either 1 step left or 1 step right, and another place to jump where array of I equal to array of the, where you have the you can jump to that index where it contains the same value as the current index. Consider you are at let's consider you are at 100, so you can jump to one right, one left, from 100 one right, one left, or the places where 100 already occurs. You can jump to 1, you can't go minus 1. So if you are standing at 100 you can jump to 1 or 2, 3, 4. You can jump to either 1 or either 4. At minus 23, you can jump to minus 23 or 404. At 23, you can jump to 23 and again 23 or 100. You can go one left, one right, and where you have numbers as same as you, where you can jump. Okay. So let's see how we're gonna solve it. So let's take an example. Let's take and what the question is stating, it return the minimum number of steps to reach the last index of the array when we have initially positioned at the first index of the array. We are every time we are positioned at here and you have to reach here. We just need to calculate the minimum possible steps. Now if we move one step right, and from minus 23 we can move another step right. From minus 23 you can move to 404, and from 404 you can directly move to 404. Okay. And if we choose this part we can move 100 to again 100, and then one step left and then 404. So it took 1 2 3 4 steps. It took 1 2 3 steps. So at minimum we can reach there at 3 steps. Okay. So like that something. So let's take this array to see how to proceed here. So for example, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So starting with 0, we can go to 1. From 1, we can go to and mark 0 at 0 as visited. From 1, we can go to 2 or 3 because 3 also contains 2. We can go to 2 or 3 and mark 1 is visited. From 2, we can go to 5 or 3. 5 or 3. And from 3 we can go to mark 2 as visited. From 3 we can go to only 4, mark 3 as visited. And now here from 5 we can go to 4 or 6, 4 or 6, mark 5 as visited. 4, from 4 we can go to 7, index 7, because 7 also have the value 4, and mark 4 as visited. So we're not going to continue 4 because we already visited 4. And from index 6 where we can go to is 8 or 7, 7 or 8, and from mark 6 as visited, and from 7 we can go to 8. Okay. And mark 7 as visited. So 7 is already visited, we're not going to continue again. And what we're going to do next is from 8 where we can go, from 8 we can go to 9 only. And how many steps we took to reach here. If we count, we took 1, 2, 3, 4, 5, 6 step. I mean, the path we took here is from 0 to 1, 1 to 2, 2 to 5, 3, 4, 5, 5 to 6, 6 to 8, and 8 to 9. And 1, 2, 3, 4, 5, 6. So we took 6 steps to reach to the last index. And if you notice one thing, while I was doing the BFS here. I mean, I have to iterate breadth for such. If you recall the last, if you recall the last lecture, what we are doing here is, what we are doing tomorrow is doing depth for such, because we just have to go to the depth. I mean, we just have to calculate that if we can reach or not. But here we have to go breadth level wise, because we have to calculate the step, how many steps we required. I mean, how many minimum steps we required to get there. So okay, so how gonna we code this approach? So first, let me let me take where you can go. So if you are at index I, you can go to I minus 1, you can go to I plus 1, or you can go wherever array of I equal to array of the thing, array of that index where you want to go. Okay, so one thing we can do, if you have to, if you create a hash map, uh, 1 contained at index 0, 2 contained at index 1, 2, 1 and 3, 6 at 9. Okay, so we can first create this table, and while doing this, so what we can do, if we are at index 1, okay, so at index 1 we can go to can 0 or plus 2, or the elements which are in this. I mean, at 1 the value is equal to 2, and 2 is also containing at 3 index, so we can go to 3 also. Similarly, if we are at 6th index that contain the element 5, we can go to 5, we can go to 7, and also we can go to another index that contain that element, that is 8. Okay, so first we have to store this, so we don't have to iterate over whole array and check. So check every time, we just have to iterate it once and store it. And also one thing, that we have to use another data structure vector. So we have to mark the indices where we have created, because we cannot mark it here, because it can contain int min, int min to int max, so it can contain any element. So we cannot just replace element and call it marked. We have to create another array called visited, where we can mark the element as 0 if not visited and 1 if visited. So, and for build for such, if you know how we're gonna implement this, we just gonna use a queue data structure to implement this. I mean, we have to do a while loop to traverse level by level, and a nested while loop to traverse to the each element of that level. Okay, like a while loop and another while. This while loop traverse the whole tree, and this while loop traverse the each level, and after this while loop we can do label plus plus after this while loop. So after completing every inside while loop, we can do label plus plus and move to outside while loop. And in queue, what we're gonna do is just push the element one by one and remove it one by one. I mean, like here, if we see here, what we're gonna do, we're gonna just push the 0 and pop out 0, and then again push the 1, again pop out 1, push 2 comma 3, and again pop out 2 3, push 5 3 4, and pop out 5 3 4. We have to do it layer by layer. Okay, while traversing this layer we can push this, and while traversing this layer we can pop out this and push this. While traversing this layer we can pop out this and push the next element, what is 4 6 7, and like that. Okay. Okay, so the data structure we are going to use here is a queue to do the BFS, and a vector called vector of integer called visited to mark, here we can have boolean to mark it's visited or not. And we need an unordered map of type integer and vector that containing integer. Let's call mpp. What it gonna store is, like, we have value 2, and value 2 was stored in index 1 2 and 3. We have value 4 that is stored in index 5 6 7. Okay, like that. So first of all, what we have to do is first populate this unordered map. So what we can do for gonna do is map of the what I mean the first element on hash table gonna be the value of that index. So we are going to do array at index I dot, and this indicates the vector, and dot push back the index we got. Okay, so first we have to populate the this, and the vector visited here we initialize. It should be of size and first mark everything as false. And now first q dot push, let's push the first index, that is 0, and mark first index at visited. Whenever you gonna push anything in queue, we're gonna mark that as visited. So mark visited, that 0 index was true. Okay, so now we just have to run the while loop while queue isn't empty, and we also have to initialize a variable called layer of integer data type. We just have to track in which layer we are. So the first while loop is traversing layer by layer, and second while loop was second while loop was doing the nodes of each layer. So I mean, to do the nodes of each layer, we have to know what is the size of that node. So size equal to q dot size. So consider something, we have 3 to 5, and we iterated over 3 and pushed 6, we iterated over 2, pushed 7, we iterated over 5, pushed 1, and we are not going to iterate over 6 because this is the another layer. So we're gonna stop here. So how many times we iterated, that we're gonna store in the size. While size minus minus current equal to front of q, pop out that element, q dot pop. And now what we have to do is, if current equal to n minus 1, I mean size minus 1, just return is, I mean layer at which layer you got this. And now initialize two more variable, int left equal to current minus 1, and right equal to current plus 1, and if left is greater than equal to 0, visited of left is not equal to 0, I mean this is not visited. So what we're gonna do is, we first gonna push left into the queue, I mean q dot push left, and mark left as visited. So, and similar for right, if right equals to true. Okay, so next what we have to do, we have to, in the third case where we have to iterate over for int index map of error of. So I wrote here is, if you look at carefully here, I mean, this is the map that we stored. So if I wrote MPP of array of current, I'm basically referencing to the value of that current index. So if value of that current index is 2, then it whole gonna represent the vector 1 comma 2 comma 3, and it whole gonna represent vector 1 comma 2 comma 3, and we are iterating over each index 1 comma 2 comma 3. So we just have to check there. If it's not visited, if it's not visited at index, what we can do is push that index into queue and mark that index as visited. We are done with the inner while loop. At we can do also one thing, that we can clear that. So mpp of arr of current dot clear. So we not gonna do again and again on that index. That saves some time to us. And this is the first, inner while loop. Outside this, what we're gonna do is just gonna do layer plus plus, because that's the end of the layer. And after doing layer plus plus, we are done with the second while loop. Second while loop is this. So that's the whole code. So let's try to first let me write this code, and I will do a dry run to explain it first. Okay, so it passes all the test cases. So now, as I said, let's try to dry run this. I mean, so we got a code, and I mean, we got the code and the example also. So let me first create the map. 5 6 7 3 is mapping to 8. Okay, so let's push the first element in the queue and mark 0 as visited. So after pushing the first element, what we got a size? We got size equal to 1. Size equal to 1. So let's do we just have to run the inner loop only once. So here current is equal to 0. Pop out the current from the queue. Is 0 equal to 10? No, it isn't. So it will not gonna return the layer. Left equal to -1. Right equal to +1. So is left greater than 0? No. Is right less than arrow dot size? Yes. Is right visited? No. So we have to push the right and mark right as visited. Mark it as visited and push the right. And now I'd set over the every index of that same value. 100, we got 0. So is 0 visited? Yes. So we skip that, we got to 4. Is 4 visited? It isn't. So mark 4 as visited and push it into the queue. And now clear this. After, and do a layer plus plus. Let's track the layer variable. Now we got layer 0 from 1. And now we have begun with second while loop. So at second while loop, we have two elements. So size equal to 2. So now iterate over this 2. So at first, left equal to 0, right equal to 2. So is left visited? Yes, it is. Is right visited? It isn't, and it is in the bond. So mark it as visited and push into the queue. So mark 2 as visited as push into queue. And now move to the hash map. We visited. Is 1 visited? Yes. Is 2 visited? Yes. So we moved to -23. Now go to the second loop that's containing 4, where current equal to 4, left equal to 3, right equal to 5. So is left visited 3? No. So proceed. Mark it as visited. Is 5 visited? Isn't. So push. So proceed and mark it as visited. And at 4 we got 100. So we already finished it 100 in hash table. So let's pop out 1 and 4. So now let's go to the third layer, do a layer plus plus, and now move to the third layer. In third layer we have 3 elements, so we're gonna need 3 inner loops. So first current equal to 2, pop it out, left equal to 1, and right equal to 3. So is 1 visited? It is. Is 3 visited? It is. And at index 2 we have minus 23, and we already finished minus 23. So let's move to the second while loop where current equal to 3 and pop out the 3, left equal to 2, right equal to 4. Is 2 visited? It is. Is 4 visited? It is. So let's remove the 2 and 4, and at index 3 we got 404, and we got 404 at 9. Is 9 visited? It isn't. So push it and mark it as visited. Push the 9. Now move to the third. Push the 9. Is 4 visited? It is. So let's remove this. Now move to the next element, that is current equal to 5, left equal to 4, right equal to 6. Is left visited? I mean 4 visited? It is. Is right visited? 23. I mean 6. It isn't. So mark it as visited and push it. And at index 5 we got 23, and we got 23 at 5, 6, 7. As 5 visited? It is. Is 6 visited? It is. Is 7 visited? It isn't. So push the 7 and mark it as visited. So now move to and do a layer plus plus. So we got to third layer. Now we have to do, we got only 3 element, we done 5 before here. So let's check for 9. Current equal to 9, left equal to 8, right equal to 10. So I mean is, and first pop out the 9. So Qt report is current equal to array dot size minus 1. Yes, it is equal to. So here we have to return and layer equal to 3. I ran the code, and the time complexity and space complexity for this code of both was big of n. The time complexity and the space complexity is also gonna be big of n, because we are not going to store more than this element in this queue, more than indices we have. And the time complexity is also gonna be big of n, because we're not gonna iterate over marked index twice. And if you consider the hash map, it's also gonna fit under big of n, so it might be space might be big of 2n. So we consider that big of n. So that's it for today. I hope you like this video. Please leave a like and make sure to subscribe to Tensor and turn on the bell notification for such interesting contents. Until then, keep smiling, keep coding.